Anyway, don't they have the copper? Don't they have the copper skillet and all that kind? Anyway, all these new coatings are polymers that they learn how to stick onto metal, and when you cook with them, they can withstand the heat, and things don't stick to them. That's a whole science of what if I want to make something sticky? What if I make it not sticky? What if I want something to never stick to something? They could do that. Okay, so anyway, the brand name Teflon came along there. Okay. But then we went in over here, and I believe that we did all the alcohols. Did we do that? We did alcohols before, didn't we? Okay, and then we went into the ring structures, right? So let's go to the ring structures again. And this is how when we got into stick structures. So I do want you to be able to build a stick structure of anything we build. Like what if I were to build, say, what's the stick structure for this guy? And what's this one? And if you build a stick structure here, this is not hexane, but cyclohexane, right? And so you just build that. At the end of every stick is a what? A carbon. Carbon wants 4 bonds. Here's 2 bonds, so it must have 2 hydrogens there. So organic chemists they know that. And you guys, actually, you know it too. What would this be called right here? What would this be a stick structure for?
Yeah,
6 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What is that? What is that called? Hexane, isn't it? So hexane is this, but what price do you pay by turning this into a ring structure? Ah, see that? You lose 2 hydrogens, right? What price do you pay when you turn this into benzene? I should lose 2 hydrogens, 2 hydrogens, 2 hydrogens. What do you think? Are you seeing a pattern now? Okay, good. This one is, the benzene ring is really, really big in organic chemistry, and this one happens to have one of these on there, and remember this is called a even though you'll find out later, it's called a hydroxyl group, but this is actually phenol. This is actually phenol, and they use that for lots of things. Then we come down here and we make the benzene ring with a methyl group or a CH3 group on there. And look at that little stick there. There it is right there. Okay. All right. And then this right here is toluene, also known as methylbenzene. Methylbenzene. And now, what if I take the toluene and add what they call a nitro group? Now, nitro group, it's not nitrate, that'd be NO3 as an ion, wouldn't it? These are not ions. This is a nitro group, NO2, NO2, NO2. And I have 3 nitro groups. And this is the last thing we made. And this is trinitro-toluene. And that's where they get the TNT from. The Alfred Nobel, when he made this whole idea of explosives and things, it did a lot of good. All of a sudden, you could blow out the tunnels and put tunnels through mountains, and you could get iron ore out of the ground, and it was a great tool. But like all things that are discovered, if humans, and we're all fallen, we're all sinful, they also used it for weapons, and they blew people up. You get that? And so actually he spent a certain amount of the rest of his life trying to do good things for people. So he made millions and millions of dollars back then. That's a lot back then. Enough to actually set up the Nobel Prizes and all that are awarded every year. So he wanted, same thing happened with some other people that made the atomic bomb. They knew that you could use that information for good, but you could also use it for bad. And so people have always had that thing about, maybe I'm going to spend the rest of my life trying to help humanity because I did build something that hurt them. Yes?
I heard that he originally started developing TNT, trying to develop it because the explosives that were used for mining were incredibly unstable while they were being stored.
Even nitroglycerin, for example, nitroglycerin, how do you transport something that's not very stable? You put it in straw, you pack it in straw, and maybe you make sure your buckboard, you got horses, and I don't know, how do you get it to the site without blowing people up? And I don't know about that. They'd have to pay a lot of money to somebody, but they didn't. They said, you want to do this? You want some money? Yeah, I need some money. Okay. And back then, they probably didn't care that much. If you got blown up, I'm sorry, but you took the job. But they, what Alfred Nobel did, by packing it in other material like sawdust and stuff like that, you could actually make it more stable. And then you have a fuse, and you have to add a little activation energy before it'll go off. And I think that's what made him a lot of money, because now I could have these sticks of dynamite, and I could transport them, and they're not going to go off. You'd have to shoot them with a bullet or something like that, but they're not going to go off, and that's where he made a lot. That's where he made a lot of money. Okay, so are you okay on these ring structures? Okay, let's go back to methane. We're going to go all the way back to methane. Here we go. And this is what I didn't get to finish the other day. By the way, while you're getting ready to do methane, can everybody look up here for a minute? This is probably the simplest ring structure you can have. Did somebody build that already? I think some of you were messing around with the ring structure the other day. This would have been propane. It's all single bonds, right? But it can't be propane because it's missing two hydrogens, isn't it? So what would you call it? Cyclopropane. You get that? And what about this guy? Cyclobutane. There's your stick structure there. And what's this one? Cyclopentane. Okay? And again, A and E means all single bonds. But now, what we didn't get to is this other group, not the hydroxyl group, but the carboxyl group. And these are called functional groups. So if COH, and again, you have other things attached to it here. If that's what makes an alcohol, then what is the carboxyl group? What's a carboxyl group? And we learned this before, and it's the Cu. Remember the Cu? Remember this? Like if you ask an organic chemist, what is acetic acid? Here's an inorganic chemist. Acetic acid. 2, 3, 2. Okay, see that? There's acetic acid. But wait, you didn't even write it like an acid. Oh, okay, all right. Wait. H2. Okay, I do that. So sometimes you'll get organic chemists. Oops, I didn't do it right. Okay, here's the way an organic chemist might do it. Organic chemists would write it like this, because they're trying to tell you that I have this COOH, that Cu thing. Now, I had never built models when I was your age, so when I saw it in college, I started, and I kept seeing books saying CH3Cu, CH3Cu. I had no idea what they were talking about. But now that you build a model, here's what I'd like you to do, is I would like you to make, this is called an acid group, organic acid group. I'd like you to make the simplest organic acid that's possible. What is the simplest organic acid that you could possibly make? There's one simpler than that. Hang on to that one. I see if you can make the simplest organic acid. I can't have any open holes. No open holes. What's the simplest? That's it. Hang on to that. That's it. Turn it around a little bit. That's it. Very nice. Wait. Yes, okay, there it is. I got it now. I got it. Make the simplest organic, and you're going to have you're going to have a carboxyl group. You're going to have a carboxyl group. There you go. Very good. All right, 4 tables so far. That's it? Yep. So, even though I never understood what Cu meant, because I never built models, but now, can you guys, do you see the Cu? Do you see the C double bond O OH? Does everybody see it? Now, if you have a C double bond O OH, that thing's going to act like an organic acid. All right, let's look up here. And so the first one you made was probably right here. Is that what you made right there?
Yeah.
Okay, now, how do we name it? Yes.
If it has an OH group, why doesn't it act like a base? Because
Okay,
it's
now,
OH.
okay, good question. I'm going to go back. And this was, matter of fact, I don't think anybody answered this. But I asked this question last week. Why is the alcohol not an acid or a base? It's neutral, yet it has an OH on it. And what's the difference between the OH and NaOH and the OH in an alcohol? This COH, this is not coming off. When I put this in water, this is not an ion. What is this before I put it in water? Ions. When I put it in water, the ions simply separate. So there was already ions, and that's what makes your base thing is the OH ion, right? This isn't coming off. So I can't call it hydroxide, it's called hydroxyl. Now let's go over here. Same thing's going on here, is there is an OH, but it's a COH, isn't it? COH? And so I have a COH here, but that's not coming off, so it can't be, it's going to be neutral. It would have been neutral, except when you have C double bond O OH, when you put it in water, look what happens. This guy here is going to come off and form a hydrogen ion, and that's why it's going to act like an acid. Now, most organic acids are weak acids, so maybe only 1 out of 100 will actually dissociate into ions. Yes?
Isn't it oxygen pulling the hydrogen away from the other oxygen? How does it?
So, which one?
Because in the way water dissociates, like the hydrogen would be oxygen pulling it away, but oxygen is also within keeping it on. How does?
I would say that when this thing is with water, does water have the ability to pull this one off? That's a good question. Why does water have the ability to pull it off here, but it doesn't have the ability to pull it off with a hydroxyl group? How about that? And I'm sure it has something to do with this double bond O here. If I remember correctly, if this is taken off, they'll end up sharing electrons and making the O's not come off. Like they'll even shift places. And so that's a good question. I may have to look that up. Why is the H taken off with a Cu group, a carboxyl, but not hydroxyl group? That's a great question. I think it has something to do with this right here, the fact that that's there. All right, well, anyway, what you made is, how do you name an organic acid? Well, most books, the most modern way would be called this ethanoic acid. So I'm going to show you how to do it. You say not ethanoic. This would be methanoic acid. Now, methanoic acid, if you ever hear that, you know, well, you only have one carbon, and you have to have C double bond OOH, right? And what's the only other thing attached to you is a hydrogen atom, isn't it? And that's the simplest acid you can have. Now, if you look up this book, in a book, though, they might have another name, and it's called formic acid. Now, I think it's a great story there because there were people who actually found in different countries, especially in jungle areas, they found people who were making incredibly concentrated acids, and none of them went to college. How in the world were they able to make acids? And they were taking ants. And they were taking ants and boiling them and boiling it down. And the ants in the body, the ants were making formic acid. I don't know if you've ever been stung by, bit by ants, like in South Carolina, that kind of thing. But a lot of this acid that ants make is this right here, this formic acid. And the Latin word for ant was formicity, I think it was. and they named it formic acid because that was made from ants. Now today you would call it methanoic acid because it has one carbon on it. That's a neat little story about the ants. Now let's make the next. What's the next step in the acid world? Not methanoic acid. Let's make ethanoic acid. Let's make ethanoic acid. Yeah, that's it. That's it. That's it. That's it. Okay, that's it. Yes. Wait, yes. Okay. How are we doing on that? You guys making it? Okay, you got it. There he is. Okay, that's it. That's it. Okay, that's it. One more. Okay, now let's talk about this for a minute, because the name would be ethanoic acid, and if you ever saw it, you'd say, I know what you mean. It's got a Cu on it, but it has 2 carbons, right? And so I could probably tell you what it looks like. I bet it's going like this. Let's do the C double bond O OH. I bet it has that on there. Yeah, you're right. It does. But then it has F. You said F, so it has another carbon, and so we'll put a hydrogen here. And there you go. So I just built it like that, right? Now, it just so happens that that thing has been named for a long, long time, and the old way for saying that it contains 2 carbons was, anybody know? What's the old way of saying they contain 2 carbons? Somebody? No?
Aceto.
Yes. What did you say?
Aceto.
That's right, aceto. And so what's another name for ethanoic acid? Acetic acid. Now, acetic acid is what's found in vinegar, right? And so if in first year chemistry, if I said, write acetic acid, you said, H, that's it, remember? And so you had H, and then what was this ion called? Acetate. And that was called acetic acid, wasn't it? And so ethanoic acid is acetic acid, and that's what's found in vinegar. Now let's do the graphic formula. Look at this, graphic. The graphic is what? CH3 and then Cu. I will tell you that if you meet, you get somebody who's been in the lab a long time, here, I know it doesn't sound right, it doesn't look very organic chemistry, but guess what that is right there? Or guess what? Okay, so what do you think that is? Ethyl alcohol. That looks weird, doesn't it? But sometimes chemists have their own little shortcuts, and they'll do something like this: ethyl alcohol. And this is how they would do acetic acid like that. All right, what do you think about the acid groups? All right, are you okay with that? One more time. Here's acetic acid, and if you put it in water, water does have the ability to pull that off, but not great, because it's a weak acid. So maybe only 1 out of 100 will have its hydrogen pulled off. But what's left here? What's this called? That's another thing I didn't understand, because I never did modern mill building. What the heck was this? What's CH3 Cu? Cu left me hanging. What's that? What is that? I'll give you a clue. What is it? What? Yeah, which one? Acetate. So this is the way in first year chemistry you'd write acetate, but how would they write it in an organic world? And sometimes they don't look the same, do they? You see how they did that? It's the CH3, Cu, and they left no H, right? That's the acetate ion right there. Okay, well, I'm going to stop that for a minute. And, eventually you'll learn all these. And when people give their presentations, you're going to learn about these other functional groups. We already know about that, and we also know about, where is the acid group? Carboxyl. Oh, it must be on the next page. Anyway, So anyway, what I want to do the rest of the period is I want you to, and if you've already read the packet, and by the way, I'd like to have that probably by the end of this week. You should have those questions done because that's giving you 2 weeks to do those. That's a lot of time. So if you haven't read that, you start reading it, and people are going to start presenting these on not tomorrow but the next day. So I would like some volunteers, and here's what I'm looking for. Okay. I'm looking for, you're going to, when you come up here, I'd like to have at least 5 minutes. I don't really want 10. I'm not saying if everybody did 10, we'd run out of time. But I'd like to have a minimum of 5 minutes, though. So run about 5 minutes. And here's what you're required to do. You're required to cover the stuff that's in the packet. So when I sit back there and listen to your report, I'm going to look on the packet and say, yeah, they did that. And I might say something like, well, didn't you want to mention something about this? You know? And so you got to make sure you cover what's in the packet. But also, I'd like you to look up something that's not in the packet that you think is interesting. Got that? Okay, now, you have to have some kind of a visual. Now, the visual could be, if you wanted to give somebody a handout, so you could. If not, you could just put something on the camera. I've had people draw on the board. They want to draw things on the board. I've seen people do that. But I need some kind of a visual aid. It can be a model. I've had some people build models and stuff like that. But you have to have some kind of a visual with you. And on some of these, most of them, they're going to have memory tricks, okay? Now, what's going to happen here is I'm going to start out. I'll probably do the first 4 pages. Can you guys have your packet with you?
Can I pass that out? It's right.
Oh, yes, I'm sorry. Let's go ahead and do that. Thank you. Does everybody have their big fat packet with them? Can you tell me, is this, what starts at 367?
That unsaturated hydrocarbons contain multiple bonds.
Say it again.
That unsaturated hydrocarbons.
Okay, all right. So this is unsaturated hydrocarbons? Okay. So somebody could do that. I'm going to do the first part. Is this right here? Is that start at 361?
Yeah.
What I'll do is tomorrow, not tomorrow, the next day, I will start out and I will teach the first 3 or 4 pages. You get that? And then I'll call up this group. And then I'll call up this group and this group. So probably on Wednesday, chances are we may only get to maybe here. And then on Thursday, everybody else will do theirs, okay? So I'm not know for sure, but I'd say we probably will get that done. Maybe we'll get one more done. All right, so I'm going to do that. I'll do that one, okay? All right, who wants to do pages 367 to 370? And it doesn't have to be your partner right here with model building. If you just said, no, I like you, but I want to do phenols. All right. Ooh, that's a neat one.
How close is the DNA base?
Well, it looks like, okay, now, all the bases in DNA are called nitrogenous bases, and so they have to have a nitrogen somewhere.
Right, I figured that was probably like right here or right here.
Okay, but they do have ring structures. And when Watson and Crick tried to develop this, they had to go visit some other people who are really good chemists, and they made little models. And they have to cut them out of aluminum or something like that. And they said, what would happen if I put guanine next to thymine? What? And they had to have somebody help them. Said, oh, you'd have hydrogen bonding here. You'd have here, And that's when they eventually figured out that A went with T and G went with C, and that's great. Except you didn't have any nitrogen in there, so I don't know what that was.
I was just curious how close it was.
All right, what do you want to do?
We'll do the page 367.
So you want to start out the thing. You're going to be first, right? All right. Wait a minute. Okay. All right, Carson. Were you going to pick alcohols?
Yeah.
Okay. I'll let them do it. Pick another one.
No, wait, just-
Okay. Next. It can be. It doesn't have to do them in order. Just tell me.
Oh, yeah, ethers.
Ethers. Okay. I'm gonna make sure. if you look at your packet, there are some parts of the packet where there's not a huge amount of information there, so you may end up having to look up maybe a little bit more. Okay. Okay, hang on. Let's see. Jeb's not here. Okay. All right. All right, we got
We'll do phenols.
phenols. Okay. Okay. Yes.
We do ketones and aldehydes.
Yes.
Work on it tomorrow.
All right. Yes. All right.
Could we do,
Which number?
6?
Amines? Okay. Oops. Ooh, frozen. All right, Jonah.
You would like to do the esters and organic acids?
Esters and organic acids? Okay.
I'll do that.
Which one? Amides. Now, you could probably do it by yourself. I'm not sure when, if Jeb doesn't come back, he'll have to just do one by himself, okay? Is that all right with you? Oh, is that right? Okay, all right. Now, is that everybody? That's not good. Nobody wants to do polymers? All right. So what'll happen is I'll end up having to do these. There's nobody else, right? Okay, that's right. So what I like to do is you have the rest of the period to meet with your group. Sorry, Caleb. Meet with your group, and what you're going to do is, and we do have a quiz tomorrow, but you'll have also the rest of the period tomorrow to work with your group. And what I would do is tonight, if you're going to print something out or you're going to do something like that, make a plan today. Both of you go home and say, it's only a 5-minute presentation, right? And the first thing is make sure you cover the material in the packet, and then look up something that's interesting that's not in the packet maybe, and then have some kind of a visual. That's all I ask, okay? And a visual could be a model. It could be something on the camera. You're going to teach a lesson on the camera, but you're going to use a visual somewhere. Yes. All right, is everybody okay? All right, you have the rest of the period to talk to your partner.
Could I get the largest?
A larger packet.
The larger one that we were supposed to read.
Yeah.
I didn't pick up on, like, I thought it was the one that we had.
Okay, because wow, what do you mean? Because remember how many times I said, well, you need to work on okay. Okay,
Like, maybe
Yeah.
maybe if
All right, hey, Tim had a good point. These questions for the package should be due by this Thursday, but what if I forget to pick them up on Thursday, then I'll pick them up on Tuesday? But you do not have any homework. You do not have any homework over winter break. So you, and I didn't go last week, so I think it should be done this Thursday, but I might forget to pick it up on Thursday. I'm not giving you homework over the break. I'm not. All you have to do is get it done by Thursday. Okay. Anyway, I always like this, I like that you get up there, you start to teach, and, I love it, so.
We probably took a picture of him. Then we have a bunch of people like.
Hey, does everybody know that, wait a minute, does everybody know you're covering the stuff in the big packet, the reading packet, right? You're doing the stuff in the reading packet, and you're gonna look up something interesting that maybe not in the reading packet.
Well, we're talking about C passes. In the book is given C2H4. It's given C2H4.
History?
All the levels we have.
That's a pure.
Oh, probably.
Yeah.
I accidentally wrote history.
We don't have history.
I was like, oh. I started to panic. I was like, I'm just about to start studying my class. I don't know what to.
Yes.
So many images. Well, this one doesn't. This one doesn't. Like the new, like amazing.
Yeah.
The mouthwash doesn't. Basically, what I got was this part talking about how it has a negative charge. It's kind of acidic, and it has a negative charge, but it's like some top potatoes is like I can get passed around. Okay, what is our memory? It's like that's what makes it like more able to hold. Is that just a negative charge? I feel like really worked out. I'm gonna make an omelet. Okay.
Hey, do you everybody know what a memory device is? Like, how are you gonna remind me what a ketone is? How are you gonna, what's my memory trick for phenol? What's my memory trick for amine, amide? So I want you to have a memory trick, some kind of memory trick.
So each phenol contains we're doing like the unsaturated and saturated
Okay, so you-
hydrocarbons. So this is just So the benzene ring.
Yeah, some of you will finish the quiz in 20 minutes, some of you won't, but, you have the rest of the period
Just read your
tomorrow
memory. So
also.
it's like
And then we'll
double,
start
single, double,
presentation the
single,
day
double,
after that.
single.
What's that?
Oh, wait. Oh, it goes double, single, double, single. I think that's pretty good.
Oh, basically everybody.
It's basically two.
Try to better explain it to everyone. And then we can print out something. If you can print out Joseph Lister and Listerine and this thing.
I didn't say anything. I thought it was too. You can't. I was like, I'm get out. Get out.
It's just this part, right? So basically it's just like,
I want people to say, you can look at a model and say, that's a good
this was, yeah,
And
penal.
then try to get them to say, that is. I got it.
So,
Really,
is it smell like something? I like it. Unsaturated. It's not saturated.
Water too, so they use this stuff like acetone. Like water, so make sure you look at acetone. That's a pretty good one.
So basically, the difference between and like alcohols and like the it's attached to a benzene ring and not just like attached to like a
Why not? What?
You can pass the negative charge around the ring. But like if you
And ether is pretty neat because for a long time,
yeah, it can like pass it around.
Is that what they use for the?
What do they use now? Because it says they don't use.
Now, you have to be, not only a doctor, you have to go way beyond being a doctor.
Oh, I think it just makes it, because like, okay, so if you have phenol acid is made of the phenoxide ion, which is this, and then hydrogen, so it's losing this to create this. Or it says, after you donate the hydrogen ion, it would come to negatively charged. You know, okay, so this is neutral, but when it donates to this, it becomes negative.
Stuff like that.
So like, it's negative, it passes it around when it doesn't have the hydrogen. Because the negative charge is not toxic. That makes sense, because I was like, what is it? And then we can briefly talk about these.
Got a good one. Yes. Yes. I'm trying to find
Well, it's this, and then that's this, and that's this, and that's this, and that's this. That's a good mix. No, it's too many.
See how it's an aldehyde?
I know it's another guy.
Best friend Al Powell, he gets stuff right in his class for.
He goes like this.
Okay.
People that can see how the aldehyde group, no, when it's coming off of this one, it's like first.
That's not what I
Tell you,
meant.
no one is in it. So when you get something right.
Yeah, I was gonna, he goes like.
He goes, he goes.
Well, I close his eyes, like, wow, even like
Every once in a while.
here's some singers like that, here's singers. Wait, they're gonna open their eyes pretty soon.
And then
because I ran out of students.
I mean, only, but like, I have like all of my essays in for all my schools. So we went through all of them, and then like for like the works, I didn't show him because I just kind of wanted to get him, and then like what?
I'm going to, still have about 3 minutes, but if you missed, I think you missed, if you want to stay today, you can, and you would have to build the models that we made last week, and that'll give you back your 10 points, but if you can't stay today, I'll be here after school day, I'll be here at lunch tomorrow, and I'll be here after school tomorrow, so, if you know you missed a day, you want your 10 points back. then you can do that, right?
Sorry.
All right, let's everybody go ahead, and if you put your tables back, everybody put your tables back.
I was interested in that, like, oh, it's I had the dream. It's very interesting. I have booked out.
You always wonder, wait, it seems like this is a real.
It's very interesting, yeah, but there's like rumors about it, and apparently like some people are questioning if it was even true. So it's interesting. Thank you.
I mean, when we go into, when we landed on
I had never done like fishing before. Like the stuff that we caught.
Thank you, Mr. Baby.
All right, bye, thank you.
Whatever you catch, you can bring it there and they'll like cook it for you however you. And we
So it's good, we have a quiz tomorrow, all right, the first 20 minutes, so it's mainly all about model building, and,
Yeah, we didn't have that one, but it was really cool because we got. Jack, and like, right after they pulled like a photo.